How to work worksheet C for chapter 7. Let's look at number 1. It says, how many moles are there in 5.03 grams of magnesium sulfide? We're going to put what we do know right here, and we're going to put down what we're supposed to go to right here and here. Alright, grams is on top of the first fraction, so we're going to write down just the word, not the number, on the bottom of the second fraction. Anytime you see the word mole in second fractions or third fractions on these kinds of worksheets, you can give it a 1. Now all we need to do is find out the molar mass of MgS. So if I look up Mg and S on here, I'll find that Mg's molar mass is 24.3 and sulfur's molar mass is 32.1, and those added together equal 56.4. So I'm going to put 56.4 down here. Then I'm going to do this divided by that will equal that. Now if this had been an equals, we would have said this times this divided by, that's called cross multiplying. We're not doing that. We're doing all of the numerators divided by all the denominators. And the answer is 0.089, or if you hit the third button and the sixth button, that would be 8.9 times 10 to the minus 2 moles. Let's look at the next one. It says calculate the molar mass of cesium phosphate in grams. Alright, so we would look up cesium and phosphorus and oxygen on this sheet, and we would find out that because this 3 subscript, we'd put 3 times 132.9, and this 1 for phosphorus would mean 1 times 31.0, and then this 4 would mean 4 times phosphorus number, which is 16.0, and all of that together equals 493.7 grams. Alright, now we're ready to start our question. How many grams is contained in 2.24 moles? So that's my known. I put it here. How many grams? So I'm going to write that here and here. Because moles is on top of the first one, I'm going to put the word mole on the bottom of the second fraction. And because everywhere I see where mole in second or third fractions, I can give it a 1. Right? And then I'm going to put this number right here. And then I'm going to go this times this. And it'll equal a number, and you can either do it like this, 1110 grams, or you can put it in scientific notation, which would be 1.11 times 10 to the third. Okay, let's look at the next question. It says, how many molecules? Now every time you see molecules, you can just kind of skip over it and say that's really particles. Okay, how many particles are there in 0.91 moles of sodium chloride? So 0.91 moles is our known, and we're going to particles. Alright, moles is on top of the first fraction, so we want moles on the bottom of the second fraction. Every time we see mole in the second or third fractions, we can give it a 1. Now the number associated with particles is Avagadros number, which is 6.02 times 10 to the 23rd. So we would punch in the calculator 0.91 times 6.02. Then we would hit the button either double E if you're on the calculator at school, and then 23, and then equals. And that number comes out to be 5.48 times 10 to the 23rd. Let's go to the next one. A vial contains 46.78 grams of nickel sulfate. How many moles of nickel sulfate is this? First, we have to find the molar mass of nickel sulfate. So we find nickel's atomic mass, sulfur's atomic mass, and oxygen's atomic mass. Okay, and we would look on something like this, or you can also look on a periodic table, either way. So, nickel sulfate's atomic mass, the whole thing added together, is 154.8 grams. That's the molar mass. Alright, so now we're ready to start. 46.78 grams is our known. And how many moles? That's what we're going to. Since grams is on top of the first fraction, we want the word grams on the bottom of the second fraction. Every time we see the word mole in second and third fractions, we can give it a 1. And so we need to put this number, 154.8, right here. So what we'll end up doing is we'll punch in the calculator 46.78 divided by 154.8. The answer came out to be 0.3022, or if you want to put it in scientific notation, that would be 3.022 times 10 to the minus third. Number 5. What is the equivalent in moles of 146 liters of ammonia gas at 0 degrees Celsius and 101.4 kPa? Now this 101.3 kPa. This is also called STP. And we don't need those numbers in our calculation. Okay, so we're asking, this is our known, 146 liters. And this, what is the equivalent in moles? That's what we're going to. Alright, liters is on top of the first, so liter will be on the bottom of the second. Moles is always going to be a 1 if it's in the second or third fraction. And so then the number associated with liters is 22.4. So in the calculator you would hit 146 divided by 22.4, and you should get 6.52 moles. Next question. During an electroplating process, 4.8723 grams of silver is deposited on a steel bar. How many moles of silver is this? The molar mass of silver is the atomic mass of silver from the periodic table. So, on the periodic table, silver is 107.868, which rounded would be 107.9. So we know that silver's atomic mass is 107.9. Okay. The question is asking how many moles, and this is our known. So that number goes here. And we're going to moles, so that goes here and here. It says grams is on top of the first fraction. We want grams on the bottom of the second. And moles in the second and third fractions always receives a 1. And 107.9 is going to go there. So we would do this number divided by that number. It equals 4.5156 times 10 to the minus 2. Now we want to keep all of these digits because our original measurement had 5 sig figs. And so we'd like to have 5 sig figs here. On previous questions, this had 3 sig figs, 3 sig figs, 4 sig figs, 4 sig figs, and so on. Okay, number 7.